Components Corporation is the global leader in the design, manufacture, and engineering of precision printed circuit test points, interconnect and testing devices, printed circuit card edge connectors, pre-formed jumpers, hardware, and battery contacts. Visit us at www.componentscorp.com.
Welcome to WDD's HotSpot. I'm Mike Luciano, Associate Editor, and in this week's episode, we have the ability to charge your device anywhere wirelessly, the chip that instantly heals you, and an autonomous robot that acts like an ordinary pedestrian. An Israeli startup known as WhyCharge is aiming to allow people to access constant wireless charging using infrared laser technology. The concept uses far-field technology, which is still in its infancy. Lasers usually bounce light between a pair of mirrors on either end of a giant medium, amplifying light with each pass. One mirror within the cavity is usually partially transparent, enabling sunlight to exist as a beam. WhyCharge took this cavity and turned it into an open unit. One of the mirrors, for example, is located in a light fixture on the ceiling with the other on the receiving device. A semiconductor gain is located in the transmitter, providing photons that are harvested by a photovoltaic cell at the receiver. WhyCharge uses a Class 1 infrared laser, which is safe under all conditions of normal use. WhyCharge also formed a design using retro-reflective mirrors instead of regular ones, reflecting light back to its source with minimal scattering. The WhyCharge uses retro-reflectors, making aligning the mirrors unnecessary. As a result, the beam is maintained even when the receiver is moving around. Devices were able to charge wirelessly at a distance up to 3 meters, a figure that's expected to grow. In addition, the WhyCharge is presently available for consumers for about under $200. Researchers at Ohio State University developed a device capable of switching cell function to rescue failing body functions with a single touch. The technology is known as tissue nanotransfection, and it injects genetic code into the subject's skin cells, turning them into certain cell types required for treating diseased or injured conditions. The process was tested on mice, pigs, and reportedly takes only a fraction of a second to begin working. The chip is simply applied onto the wounded area and then removed. In lab tests, researchers applied the chip to injured limbs of mice with little to no blood flow. The chip reprogrammed the mouse's skin cells to become vascular cells, and researchers began noticing improvements in the mouse's condition within a week. Active blood vessels even formed by the second week, and the subject's legs were saved by the third week without requiring additional treatment. The chip is loaded with specific genetic code or proteins that's placed on the skin, after which a small electrical current creates channels in the tissue. DNA or RNA is injected into the channels where it takes root and begins reprogramming the cells. The study was published in the Nature Nanotechnology journal, which reported the technique worked with up to 98% efficiency. This technique uses a patient's own cells without relying on medication, so researchers expect to begin human trials within the next year.
Engineers at MIT have developed an autonomous robot that has socially aware navigation. This means the machine can keep pace with the general foot traffic and observe the rules of pedestrian conduct. Described as a knee-high kiosk on wheels, the robot recently was tested at MIT's Status Center. There, it avoided bumping into things and kept up with the average walking pace for 20 minutes at a time. To give this little guy self-driving capabilities, the team faced 4 main challenges: localization, perception, motion planning, and control. To remedy these issues, the team used an open-source algorithm to map its environment and determine position, as well as off-the-shelf sensors, including webcams, a depth sensor, and a high-res LiDAR sensor. In the future, the team plans to learn how the robot might handle itself in crowds in a pedestrian environment. But until then, they'll present their current research at the IEEE Conference on Intelligent Robots and Systems in September. That's all for this week's episode. Be sure to check in on Facebook and Twitter and catch past episodes at wirelessdesignmag.com. For the WDD channel, I'm Jennifer De La Osa. Thanks for watching.